Okay, we're going to have a couple examples of geometric series just so you get a little idea of how to fit the terms into that geometric format. So remember, the format we're looking for is a times r to the n minus 1 power. So that's the format that we're looking for to determine if a series is geometric. Okay, so that's our geometric series format. Let me write out some terms and then let's see if we can fit them to that geometric series format. So how about 3 plus 3/4 plus 3/16 plus 3/64. And we could continue that pattern. You may have already spotted part of that pattern, which is great. When you can spot part of the pattern right off, that makes the job a lot easier. So the first thing I'm going to recommend for you to do is to see if you can find the a by simply looking for a common factor that you can take out of all these expressions. Hopefully you recognize there's 3's everywhere. Let's take a 3 out to the front and let's try to let a equal 3. So if I have a 3 in each one of these terms, look to the second term because that's where the ratio is to the first power, right? 2 minus 1 is the first power. What fraction would you have left right there? When you take the 3 out to the front, you have a 1/4. That's your candidate. So let's see if 3 times 1/4 to the n minus 1 will make each of these terms. When we're looking for the first term, 1 minus 1 is 0. 1/4 to the 0 power is 1 times 3 is 3. That one works. When we're looking for the second term, 2 minus 1 is 1. 1/4 to the first power is 1/4. 1/4 times 3, 3/4. So far so good. Let's check the next couple and we should be pretty safe. When we're looking for the third term, 3 minus 1, that's 2. 1/4 squared, square the numerator, square the denominator, 1/16 times 3, 3/16. I think we're in good shape. When we're going for the fourth term, 4 minus 1, 3. 1/4 cubed, cube the numerator, cube the denominator, 1/64 times 3, 3/64. Okay, so we found our basic format here, and so we could write this infinite series as a sum of numbers from n equals 1 to infinity, a sum of terms that all fit the format 3 times 1/4 to the n minus 1 power. So this is clearly a geometric. It fits that pattern. Now that may or may not always be the case with various series that you work with, but you always want to take a look for geometric if it seems like it's a possibility, simply because it's so easy to determine convergence. So the convergence test, again, this is going to converge. So a geometric series converges if the absolute value of r is less than 1. So let's check. The absolute value of 1/4, is that less than 1? Yes, it is. So we know this converges. And then it converges to a over 1 minus r. So that's going to be a, 3 in this case, 1 minus 1/4. So that's 3 divided by 3/4. Invert and multiply, and you'll see this infinite series converges to the value 4. So when you add up all the terms that are produced by indexing through from 1 to infinity, you get exactly 4. Okay? So we want to take that same approach each time when we're looking at possible geometric series. And when we're looking at a series that we have no idea what it might be, we always want to take a look and see if a geometric series seems possible. What's a possible clue that a geometric series is in the mix? Anytime you have fractions in your terms, whether it's in every term or in some of the terms, you want to give it a look and see if geometric might be the case. All right, let's try one more example. Let me get a fresh piece of paper here. Here's another series that we're going to try to fit into this geometric format. So from 1 to infinity, our format again, a, r, n minus 1. So we want to get that kind of familiar in our minds. My infinity got a little out of shape there. There we go. All right, here's some terms. 1/9 plus 1/27 plus 1/81. And we could continue that pattern on. Now, let's see if we can fit this into that geometric series pattern. So the first thing I want to look for, again, just like the last time, is there a common factor I can take to the front? So take a look at those. Clearly the numerator is a 1, so I could take a 1 to the front. Is there a common factor in the denominator between 9, 27, and 81? And I notice that 9 divides into all of those. So I'm going to try 1/9 as my a. If I take 1/9 out from this second term, because remember the second term will often tell us our ratio. If I take 1/9 out of that, what am I left with? And when I look at that and I think of that question, I think about this. What would the two factors be that would multiply to give me 27, 1/27th, if I had 1/9 as one of them? I would need a 3 right here because, of course, fractions would multiply straight across top, straight across the bottom. So I'm thinking a candidate for my r is 1/3. Okay, let's check that and see if it produces each of the terms that we have at hand. The first term, 1 minus 1, that's a 0, times 1/3, that's a 1, times 1/9, 1/9. Second term, 2 minus 1, that's a 1, so 1/3 to the first power is 1/3, times 1/9, 1/27. That's great. Now let's go for the third term. 3 minus 1, that's 2. 1/3 squared is 1/9 times this 1/9, that's 1/81. I think we found it. So now let's go ahead and write this in our format. And let's see if it converges. So we know this converges if the absolute value of r is less than 1. All right. So the absolute value of r, in this case, r is 1/3. Is that less than 1? Yes, it is. So it converges, and it converges to a over 1 minus r, where a in this case is 1/9 over 1 minus r, which in this case is 1/3. So 1/9 divided by 2/3, and when I invert and multiply I get 3 in the numerator, 18 in the denominator, so that's 1/6. So there's a couple examples of how to work with a geometric series to take a series of terms and fit them into that geometric format. Things can get a little messy if there's positives and negatives in there. My advice would be find the numbers that work, and then if you have positives and negatives in the terms, try slipping a negative into your ratio, because that exponent will cause that negative to either show up when you're in a odd numbered term, or to go positive when you're in an even numbered term. So find the numbers first, then try slipping in a negative there or slipping in a negative out here to get the signs to work out. All right, I hope this will get you rolling on your assignments. Thanks for stopping by.